dock with, and this defines the point on the surface that it's actually going to try and use and dock with. So that's it for this particular area here. This option here, lock on target object, what that actually does is when you're defining your object target here, it's going to use a random value. Now this can actually be constantly active, so random only gets applied once, but closest pivot, that can actually change over time. So if we're trying to reach our nearest pivot point, and that pivot point was to change during the simulation, the particle would actually be allowed to change its target and actually try and go for the new nearest pivot. So if you don't want that behavior, just have lock on target object turned on, and that will actually pick a target for the object, and that will actually pick a target for the particle as it enters the event, and then will lock that particle onto that object. It'll just keep that target, and it'll hunt that target down, as it were. Okay, let's have a look at the next couple of options, which are the docking direction. Now this group actually allows us to define how our particles will attempt to dock with the target, if they try to dock at all, that is, and also the distance at which they will start to do so. Let's have a look at the options. You can see you have none specified, and this is the default option. When this is active, the particles will actually not take docking into account at all. They will simply try and reach the target point in as direct a manner as defined by the other parameters as it can. The next option is along icon arrow, and this option is the one defined by the test custom icon rather than the usual particle flow icon arrow. Using this option, the particles will try and approach their target from the direction defined by the icon's arrow. Simply rotate the icon to define a different direction. Icon spherical. With this option, the particle will try and dock with the target based on the direction of the arrows in the icon. This option probably makes more sense when it's used with the actual icon, as the target and the surface point may differ. If you're using meshes and you're actually trying to define the docking direction using this option, as you can see here, here's the icon, then you're going to have quite weird results. The next option is icon cylindrical, and this is a similar option, but in this case the icon's vector arrows form a cylindrical pattern which actually face in towards the central axis of the icon. Again, it's probably best used with the actual icon itself rather than with meshes, because with meshes you're going to have a different surface topology rather than just a simple cylinder, so you're going to get strange results. The last option, which is surface normals, this option will actually allow you to try and make each particle dock with a surface in a perpendicular manner to that surface's normal at that point. On the icon, this option will have a very similar result to the spherical icon option, but it comes into its own when it's actually used with a target mesh. Now, in this case, we don't have a fantastically great scene to actually demonstrate this stuff, but let's try and have a look at how these particular options work anyway. We have, let's go back to non-specified, and I'm actually going to choose closest surface, and I'm going to choose closest pivot. That'll make sense. There we go, and let's try pressing play. I can actually reduce the acceleration limit down to 600, so the particles take more of an arc, and I'm going to change the ease in so it's a little bit more relaxed, and the point is the closest surface. Let's try random so we get a bit more of a spread. Okay, so there we go, we've got our particles coming in and they're docking with the surface, but there's no particular plan there. Let's try along icon arrow. There we go, so there's our arrow, and if we rotate that arrow we'll actually get a different docking direction taking place. So let's try rotating that. There you go, you can see the particles are now trying to come in from this side, and in this case this is causing big problems for this particular set of particles. This direction is actually relevant to the surface that they're trying to dock with, so it's not actually relevant to the icon. All we're defining here is a direction using these arrows. So there you go, you can see the particles fly around and they try to come in from that direction. If I swap it around, the opposite is true, and if I spin it all the way around, you can see they'll try and actually come in from underneath, and that's going to cause the particles havoc really, as they try to get all the way down to the bottom, fly all the way around, and come in from the underneath. But you can see they do actually